Hi everyone, welcome to today's class. We are going to talk about views in SQL Server. So if you remember, yesterday we talked about tables, right? And also we talked about what are the different naming conventions that we follow when we are defining any objects in SQL Server, right? Today we are going to talk about uh, views. And once we complete the views, we are going to revise everything that we have learned so far in terms of the concept, right? So let's talk about view. What is a view? In SQL, a view is a virtual relation based on the result set of a select statement. That means whenever we want to get the data from the tables and different relations, we use a select statement to get that result, right? And on top of that select statement, we can define an object which is known as view. So a view is nothing but it's a virtual relation which is based on the result set of a select statement. A view contains rows and columns just like the real table. The fields in a view are fields from one or more real tables in the database. In some cases, we can modify the view and present the data as if the data was coming from a single table. So there are various things related to view. One of the thing is that you can use views in the same way that you are using the table. You can also restrict the data that is coming from a table by using the views. So there are a lot of things that are there around views. Let's first understand the syntax, then we'll come on to those things. The syntax of the view looks like this, like create view, view name as, and then we use the select column names from table name. After that, optionally, we can use the where clause as well. That means we can filter the record on the basis of something, and that's how we define the view. So let's also try to understand that what is the difference between the tables and views then. When we say relation, it could be a table or a view. There are three kinds of relation. The first relation is the stored relation. That means something which is physically stored somewhere. That is known as the table. The table are something which are physically stored. We sometimes use this term as a base relation or a base table. Then comes the virtual relations. Virtual relation is something which is not actually stored, but it is just in the form of some query and all. And that is what the view is. So that is also the main difference between the views and the tables. And then comes the temporary results. Temporary results are nothing but a simple select query that you are not, creating some object out of it. Like when you define a view, you define the object, actual object, like, okay, this is stored relation would be known as views, something like that. But the third format of it would be keeping that as a temporary results and using it somewhere. So from here, let's try to create a view, right? So this is an example of creating a view. And why do we need views? There are multiple reasons for that. So one of the reason may be if you want to make your complex queries to be simpler. That may be one reason of creating a view. The other reason could be also like if you want to hide some data from some particular user. In that case, also you can create a view. So let me first change my database to bash 266. I've changed my database to bash 266. Now inside that I have many different tables, right? Suppose that let me check what is the data there is. Select start from employee. If I look into the employee table, we have six different employees and they have employee ID, employee name, and designation. So suppose that for some users, for for some users or for every employee, right? We have this database in the system where the employee database is there. Now, from some of the users who are not the manager level, you want to hide the designation. That means you don't want to show the designation to any employees whose designation is not manager or something. So if you want to do that, what you can do is that on top of this employee table, you can create a view, create view, vw underscore employee. So this name, you can give any name. The main thing here is that you use the create view statement, and then after that you use select emp id ename from employee. Now once I define this view is now created. I can write it loud. While there is no difference between how we get the data from the views and the tables, so as you can see, there is no difference between how we query data from the views or the table, but the difference here is in the results. Why? Because I have defined the view like only these two columns. So what you can do here is that for anyone who is ever manager, you can give the direct access to the table. For anyone below manager, you can give access to this view. So this is one of the example of in which situation you should be using the. The other thing is that suppose that you have a lot of columns in the table, but as part of your requirement, we are just using, suppose that we have 50 plus columns in the table, but we only use 10 or 15 columns out of that. So in that situation, what we can do is that we can create a view with those 10, 15 columns. And then instead of using the whole tables, we can just use that view. So there are benefits of using the query in such a way, because again, SQL Server will not have to go through the values of those 50 plus columns. It can get the values from just this 15 columns, right? So that is one example of using the views and all in such a situation. So these are some of the use cases of views that we have. Now again, creating the other use case can be, for example, let's create another view and let's understand what can be the other. So I can write create view. I'll not put vw underscore because again, this thing is totally optional. Whether you want to give any name, you can give that. So create view employee details as, after that I can write select star from employee e inner join employee department ed on e dot empid equal to ed dot empid, right? And then using few columns from both the table e dot ename e dot designation ed dot d. Suppose that I want to get the some columns from multiple tables, right? And then instead of using two joins, what if I have five different table joins here, right? Just think like that. So what we can do, instead of using those five joins everywhere, suppose that this is something I'm using this type of query almost everywhere in all the store procedures that I'm defining or all the other queries. So what I can do is that I can create a view out of this. Now this view is created. So instead of using this query, I can replace that query by using this view only. Instead of using all of that, I can just write select star from this view, and you can see that I got the data that I was looking for. Instead of using this whole, if the other reason, other thing that I could use is this long query, right? So the view can also make your queries shorter, right? You can see that how much words I actually saved by using the views, right? The other thing, securing view. A view could be used from inside a query, a store procedure, or another from another inside another view. By adding functions, joins, etc. to a view, it allows us to present data that exactly we want to give to the user. Right? As I was showing that instead of using this whole query, I can use this view here. Select star from employee details. Now I can filter on this view as well. For example, where the d name equal to IT. So something like this I can give, and you can see that now I'm getting only those whose department is IT. The same filter I can put it here as well, but as you can see, the second query is actually longer than the first query. So this is because in the first one we are using a view whose definition is like this, and then we are filtering on basis of that. While in the second one, we are just using a long query. Now, suppose that in the view only you want to do this where operation, you can do that as well. For example, if I want to drop a view, how I can drop a view? I can use drop view, then name of the view, which is here employee details. And then I can create a view like this where d name equal to IT, create view name. Now, if I remove this here, you can see that I'm getting the same result here because I put that filter inside the view. If I have to write a query equivalent of this using tables and all, I'll have to write this big query, which I'm getting through this view. So this is the purpose of using the view. This is one of the important things related to the view. Now, one of the thing here is that you can join views and tables together. That means as we can join two tables together in the same way, we can join the tables with the. For example, in this particular case, I can give ed ved inner join employee department ed on ved dot dname equal to ed dot dname. And what I want to get here from this ved dot designation ed dot department ID. So here what I've done is that I have joined a table with the view, right? And here you can see that now on the basis of this column, because this is the column between this view and this table, right? So I've joined on the basis of this view and this table and I've got some results. So as you can join the between two tables, you can join using the views together and views with the table as well. So views are can be used in the same way as we have the tables. So that is another thing that you'd like to remember, that suppose that in future you are getting a lot of complex queries together, you are using those type of queries in all the different queries. It's better to create a view in place of that query and then use the views everywhere, because view can be used in the same way as the tables. So this is another example of how we can query the view. I've already shown you all of that. Right? Now, renaming attributes in a view. This is another thing we can do in the view. We can rename the column. For example, as of now, this is the name of this column is designation. This name of this column is department and all. I'll again drop this view employee details because now I'm going to rename the column. So that is another thing you can do as part of the views. You can rename the columns with some different name. For example, for this column, I can say employee name For designation, I can just say maybe designation, and this one I can say department. This one I can just leave it like that, just to show you. So I can create the view like this. Now I can go and I can query this view as well directly. So let me write the select statement here. Select star from employee detail. If I run this, I'll get the data from this view. But as you can see, now the name of the columns is also changed. So what I've done is that I've used different column names inside the view definition. And now, as you can see in the result set, I'm getting the same result. That means the E name changed to employee name. The designation is still the same because I'm not given any alias for that. And then the D name changed to department name. So this is another thing that you can do inside the view. Modifying view. When we modify a view, we actually modify a table through the view. Many views are not updatable. Here are the rules that have been defined in SQL for updatable. Many times we want to run the update statement for the views inside the. So if you want to update a view, that is possible, but there are some rules and regulations related to that. Selecting, that is select not select distinct some attributes from one relation are which may itself be an updatable view. The while where clause must not involve are in a subquery. The list in the select clause must include enough attributes that will allow us to insert tuples into a view as well as the table. All other attributes will be filled out with null or the proper default value. So for example, you want to insert into a table with the help of a view. Can we do that? That we can do, but we have to see that first of all that we have enough columns from the table in which we want to insert in the view. What does it mean? It means that suppose that you have this employee department table, right? We have this table here. Now, if you see the column definitions of this, employee ID, this allows null. Department ID, this doesn't allows null, but this has the identity column on top of that, so this is fine. And then we have the department ID, right? So that means that for the employee ID, even if I don't have any value, that is fine. So can we insert into this employee department table using this employee detail view? Can we do that? Definitely, I think we can do that because we can insert inside the department name here, right? We can do that. So through this view, we can actually insert inside this employee department table. So let me first of all change the definition, remove this where clause altogether from this view. Let me drop this and then recreate it. Now I will use insert into statement in a view. Insert into employee details. And then I'll give the column names for which column I want to insert. So I'll give just D name. Values. And here I'll give the value maybe ministry something, right? So I want to insert the value into D name. When I'm inserting the value into D name, which table it will affect? It will affect the employee department table, right? So let me do that. What I'm getting is that this is the invalid column. Why I'm getting this? Because if you see, we have renamed the D name to with department name, right? So we should be using the department name instead of D name. That is what makes sense to the view. So once I do that, You can see that one record is affected, right? So let's check the base table, which is the employee department table, to see if we have any record inserted into that table. So employee department. You can see that we have just inserted a value. That means the D name equal to ministry just now, right? And because we have not given any employee ID for this, so that's why you can see that the employee ID here is null. In the same way, if I want to insert data into this employee table using this view, can I do that? In the employee table, we have three columns. The employee ID is again identity column and it's not null, so that is fine. Employee name we can insert through this view, and then we can insert the designation as well. That means I can insert into this table as well through this view. Let me show you that as well. Employee name, which is actually e name, then designation. So employee name, I'll say maybe Tom. Designation, maybe I'll say IT head. Okay. And if I try to insert this value, let's see. So you can see that I got this message one row affected. That means the record got inserted into the table. Let me check that whether we have a Tom thing in the employee table. So you can see that we have this Tom here in the employee table, right? So whose employee ID is Tom. Sorry, employee name is Tom and the designation is IT head. So through this view, I was able to insert into both the tables, both the underlying tables. What if I want to actually insert in the view and I want to insert into both the tables together? Is that possible? Let's try that. So I'll write employee name, designation, and then department name, values. Then maybe I'll put Jerry, answer 10, and then department again I'll put IT. If I try to insert this into both the table through this, then you'll get an error message. The error message says views or function employee details is not updatable because the modification affects multiple base table. So as you can see from this error message itself, you can see that what is the error that we are doing here is that when we tried to insert into just the employee department table, that was possible using the view. When we tried to insert using on the employee table, that was also possible. But when we tried to do insert a statement, which is actually trying to insert into both the tables at the same time, that is not possible. So that is what was written there in that thing. That is one of the major restriction of the views. The list in the select clause must include enough attributes that will allow us to insert tuples in the view as well as tables. All other attributes might be filled out with null or appropriate. So this is actually saying two things. One is that when we were inserting into this employee department table, right? Employee department. What if when we have just inserted department name, what if the employee ID would be a foreign key and it would not allow any null value? In that case also this would fail, right? So this is one scenario which we have to take care of. Suppose that view is not having the column which is there in the table and which is a not null column, and it doesn't have any default value. In that case you can't insert through the view into that table, right? The other thing is that whenever we are doing update or insert a statement on a view, that update or insert a statement should affect only one base table. We can't update multiple tables at the same time using the update or the insert statement. So that is the second limitation of the view. So you can always run the query 1, query 2, but you can't run this query, which is actually trying to update into both the employee and the employee department table. I hope this is clear to everyone. In the same way, you can delete data from the base table using the views. But you have to make sure that your delete statement is taking into consideration of one base table. If it is taking into consideration of multiple base table, that delete is not possible, right? So we have to always make sure of whenever we are running insert, update, and delete statement, that should affect just one base table. If that is the case, that statement would be successful or you will get the error message. Same for the update. So if we are doing the update, that update should affect only one base table. If you want to drop a view, right? So you can use a drop view name, right? In that case, the view get dropped from the database. So just to summarize what we have learned so far. So basically view is a virtual relation, right? So why do we need views? So view is used for storing either the complex queries or restricting some of the columns, right? For example, we had 50 columns. We just want to show 10 columns out of that to the user. That is the situation where you can use the views. The other situation is like if you have tens of different type of joins, right? And that type of joins you are using almost in all the queries. So instead of using those 10 joins all the time, writing that line of code, you can create a view and you can use the views instead. That is the second thing where you can use the views. So these are some of the use cases of having the views in place. Any questions so far? Okay. So let me go to the other topic, which is about the same thing that we have done so far. I just want to repeat everything that we have covered so far. So this, I'll try to go a little faster because again, this we have already studied. But if you have any question in between, you can definitely ask, right? So let me start from the table. We have already gone through the table, what is the table and all of that. So here I'm just taking an example, right? And I'm trying to explain the different components in the table. Suppose that we have a product table in the SQL, right? So this product is the name of the table. What we have the column names here is the P name, price, category, and manufacturer. So these things are known as attributes, right? So attributes is a logical name for this table columns, right? Then we have the rows where we store the data. So we have this row 1, row 2, row 3, row 4, right? Which has the data. So this is known as tuples. So rows we can say as tuples as well. If you have to represent the schema of a table, right? So the schema is nothing but it's the table name and its attributes. If you have to show that, you can show it something like this. That means product, then in brackets the name of the columns. All the tables, if suppose that your table has a primary key, right? So how do in the schema diagram, how to show the primary key? So whatever the column is the primary key, we underline that column in order to show that, okay, this is the primary key column of my table. For example, in this particular example, we have primary key on the P name. So that's why you can see that that column is underlined. Then we have the data types. We have already talked about the data types. The major atomic data types are characters like char 20, varchar 50, etc. So you already know that in which scenario we should be using char, in which scenario we should be using varchar. In the same way, in terms of number, we have int, big int, small int, float, tiny int, and all of that. Then we have other data types as well, like money, date, time, date, etc. So whenever we define a column can have a single data type. It can't have multiple data types. For example, suppose that you have defined an employee name. Employee name can either be varchar or it can be char or it can be int. Whatever you think is the right way of storing that data, you have to define that data type for a column. And you can't define multiple data type for a single column. That is what we mean by atomic, right? So each column can have a particular data type. Again, we talked about tuple. A tuple is nothing but a record. For example, there are 5 columns in a table, right? A tuple would be consisting of one row which is having all those 5 values combined together. So this is how we write a SQL query, basic SQL query, where we use select, then the column names or the attribute names from table name, right? Here we can use the joins as well. That means we can either use one table or we can use multiple table, or we can use combination of table and view, and we can join between them, right? And then we can use the where clause to filter the record set, whatever way we want to filter the record set. So suppose that we have again that same product table that we talked about in the first slide. What if I use a filter on the record set? That means I put a where clause on the category here. So as you can see, I have a category column which has 4 different results set, where the category are actually 3: gadgets, photography, and household. So if I put the filter, select a star from product where category equal to gadgets, I'll get something like this. So this is known as selection of data. That means we are trying to select only the required column by using some filter. Sorry, only the required values or only the required rows. So you can see that now, because we have put the filter on this category, this row and this row is getting eliminated, and we are just getting the first 2 rows. In the same way, I can put that filter on the price as well, right? And I can restrict the number of columns that I want to show. So as you can see that here we have 4 different columns: P name, price, category, manufacturer. So what I'm trying to do here is that I'm trying to get only few columns, 3 columns from product where price is greater than 100. So you can see that with this, what I'm doing here is that I'm just selecting few columns, which is known as projection of data, and then we are also filtering on the data. That means price is greater than 100. That is known as selection of data. So if you have to show this in the terms of notation, you can show that the product, it had 4 columns: P name, price, category, manufacturer. That is the input schema. When I use this query, then the answer is like P name, price, manufacturer, only these 3 columns, right? The like operator. If you remember, we covered different ways of having the like operator, right? So either you can use 2 times percentage, or you can start from something and then use the percentage, or you can use the percentage and then after that something, and all of that. So these are the different ways we can use the like operator, and accordingly the data would be filtered. So where do we use the like operator? We use it with the where clause. That means where the column name like, after that you can use any format of the, and that situation is known as the pattern matching. Also, if you want to eliminate the duplicate from your result set, you can use the distinct keyword, right? So for example, if, as you have seen in that particular table, you have the gadgets column 2 times, right? If you use just the select category from product, you'll get 4 different records, and the gadget should be there for 2 times. If you want to eliminate the duplicate records here, you can use the select distinct category from product, and that will give you only 3 records. Ordering the result set. Now we have already talked about order clause as well, order by clause. So basically in the order by clause, you can, by default, we have the ascending order. That means it's in increasing order. But if you want to give a decreasing order, you can use DESC keyword. That will change the ordering to the descending order. Now you can do the ordering on multiple columns as well. So that means you can use the order by after that multiple columns, and then you can choose accordingly on which column you want to give ascending, on which column descending, or if you want to give both ascending, that is also fine. Both descending is also fine, right? So you can, with order by clause, you can use multiple columns there, 1 2 3 as per your requirement and all, right? And again, how it works is that, for example, the SQL Server will only go to the second column. For example, here we have written order by price and rename, right? So it will be there with the price until we have a variation in price. If suppose that two columns have the same price, sorry, two rows have the same price, then only it will go to the second column. That means the P name, to now find out which record we should order first. Otherwise, if all the prices are different, it will never use this P name column in the ordering of results. Now I have covered some of the queries so far. I just want to understand now from you guys, how much do you understand all this SQL, right? So just go through the above table where we have some data, right? And then we have three queries here. I just want to understand from you that what is the result set of these three queries. The first query is select distinct category from product order by category. So we are trying to get the distinct category from this product table. The product table is above, which has four different records and four different columns, right? So we just want to get the category, that means the distinct category, and we want to order the result set as per the category. So as we have not given any particular order name, so that's why it would be ascending order, right? So who would like to tell me that what is the result set of this particular query? Anyone wants to tell me? It's fine if your answer is not correct, but at least try to answer. I'm not going to take any specific name and all, but from your end, you should definitely try, and you should try to answer, because that will definitely help you in actually getting the confidence that you are looking for with SQL Server and all. So this is just a basic query, and I think I've already covered all of this at least 3 4 times now. That is the only purpose that I repeat the same thing again and again, for you to get it. If you're not able to get it in once, try to get it in second or third instance.
Yeah, so the first one would be the select distinct category from product order by category would be the output would be uh, gadgets, households, and photography.
Correct. So why we have the household after the gadgets? The reason is again this order by clause. With the order by clause, we are just trying to order the result set on the basis of that particular call, right? And that's why Chris answered that this is going to be gadgets, then household, and then photography. Perfectly correct. Then we have the second query. Anyone else wants to answer this? Select category from product order by key name. Here we are getting the category only, right? But we are ordering the result set on the order by clause, which is on the other column, which is the P name column, right? So again, you have to think in the same way, which column we want to get. That is the only column that would be visible in the result set. And then you have to order the result set on the basis of the column P name here. And again, because we have not mentioned whether it's ascending and or descending, then it would be always ascending. Anyone wants to try this one? If you are not able to answer this one, what I would suggest is that go through the previous recordings again and try to learn it from there, because this is definitely not helpful. So
So it would be gadget photography. Yeah, yeah. So gadget. Um, it should go by the order of the P name, alphabetic order, but
Hmm.
then it will only give the category. So I'm just counting A, B, C, D. So
Yeah. So right, as you said,
yeah, gadget, household, gadget, photography.
so this is the correct answer. I hope that everyone is getting what Chris is saying. So if you want to be in the same context, you need to again go through the previous classes again, because this is a very basic query in terms of the real life example. Will not have such simple things in the real life. And if you want to come to that level, you need to have that basic understanding, right? And that will only come if you try to go through and focus with everything. And today again, I'm going to send you the second assignment, right? If you work on those assignments, that will definitely help you, because I've been doing this for more than 7 years now, and I've seen people going from zero to expert in SQL Server, right? And this is how it comes. So you need to do that practice on your own. So now the third one is again select distinct category from product order by P name, right? So here the only difference is that in the second one we have used the category, but in the third one we are using the distinct category. So here the thing again it will work like we'll get first of all gadgets, right? Because again this G is what comes in the alphabet first. Then after that we'll get the household, because after G M comes, and we have sorting on the basis of P name. So after gadgets, it would be household. Then after that, again, the third thing that should come is gadgets, because after M we have P. But because we have used distinct categories, so because and gadgets were already there, so this would be skipped. After that, we have the this one, that means photography. So it would be gadgets, household, and photography. That would be the result of the third floor. Now let's talk about the keys, primary keys and foreign keys. So you can see here we have two tables here. First is the company, which has three columns: C name, stock price, and country. C name is the primary key column of this company table. In the same way, we have the product table, which has P name as the primary column, and it has manufacturer as well. So manufacturer is actually the foreign key here for the product table. Why? Because that table is that column is actually linked to the C name column in the company table, and C name is the primary key column for the company table. So that is how the foreign key always look like. That means that that column would be a primary key column in some table, and then we are using that column in some other table. That is how we have the parent child relationship, and that is known as the foreign key. Now again, we can use the in the same way that we have used uh, this query, we can actually use the joins as well, right? So there are many ways we can use the join. As of now, what we are learning and what we should follow as well, we use table name, inner join or outer join, whatever join you want to use, left outer join, right outer join, inner join, etc. Then what how we are using it? Table name, inner join, table to name on, then we are giving a join condition. That can be one way of using the joins. The other way you can use the joins is again what we are doing here. You can see that we have the join between the product and company, right? And we are just using comma. So that is another way of writing this query. For example, this particular query, if I want to write in that notation, comma notation, how I can write? Select employee, comma, employee department, employee, I'll give it a name P, this ed, where e dot empid equal to ed dot empid. If I run this query, I'll get the same result as the above query. So this is another way we can use the joins SQL Server. And that's how this query has been written, right? So I just wanted for you to understand this querying pattern as well so that you don't get confused. Okay, what is this? I have not learned this way, right? So that's why I've covered the join in this way here. But for better readability, we should be using the inner join, outer join, and those type of keywords, because that will actually give you the better readability and everyone can understand, okay, you're trying to use the inner join, you're trying to use the outer join, and things like that. Again, in the similar way, you can use this joins and you can filter the results set on the basis of that, right? So there can be various examples of that. Again, this is a question. I'll skip this for now. So you can see that what we are trying to do here is that we are trying to put up some filters on the query and we are trying to get some results set on basis of that. Now that filter can be used in various ways. One of the filter is actually it can be on the uh, so for example, what we have is that we have the person table here which has the P name, address and works for. These are the three columns here. Then we have the company name which is C name and address. Now this works for actually is the same thing as the C name here. So works for is actually the foreign key, you can say, in the person table. So in the first query, we are trying to get select distinct P name address from person company where works for equal to C name. So what do you think, the first query will work? No, it won't work. Why it won't work? Because SQL Server will get confused here. It will think that which address we are asking for, whether we are asking for the person table address or we are asking for the company address, because we have the same address column being used in two different tables and we have joined these two tables here, right? So that means if you are using address just like that, SQL Server will throw you an error because the address column is actually in both the tables. So you have to specifically mention to SQL Server, okay, from which table you want to give this address column, from where you want to fetch this address column. So it can be either person or company, and accordingly you have to use the dot notation to give that. That means either you'll use person dot address or company dot address. So you can see that in the below query we are using the same, and that is the correct way of writing such queries. Then we have some thing called subqueries as well, right? What is a subquery? Is that inside a query you are using some other query. To understand using example, for example, what I can do is that uh, here you can see that we have a condition, right? I can here on top of that I can write where e dot empid in select empid from employee where empid or emp name ename like a, right? So this is an example of a subquery. Why it's known as subquery? Because here we have the multiple queries together. We have a outer query and we have the inner query. What is the outer query? Outer query is something which is actually which gives us the final result set. So this is the outer query. What is the inner query here? This is the inner query. So first of all, SQL Server will execute the inner query. It always executes the inner query first. That means it will type to get the employee ID whose e-name is like this. So through that, I'm getting this employee ID one only. So then whatever result set it got, that means here one is the result set of this. Then that it will execute this query and in all, and it will filter on the employee ID where the value is one. It can be multiple values as well. depending upon the situation, but this is the result set that we got, right? So this is this particular example is known as subquery, and we sometimes use this, right, to evaluate some of the things. Like here, what we wanted to do is that we wanted to get some columns from both the tables, that means the employee and the department, and also on the we wanted to get only those employees whose employee name was like A, which was starting with A. We wanted to get only those employees. So you can see that we are getting those employees only whose name is starting with A. So this query again can be written in multiple ways. So this is not the only ways, but the purpose of covering this was just to explain you that we have a concept known as subqueries as well in SQL Server. Now again, to remove duplicates, what we do is that we use the distinct keyword, right? Aggregation. We have several type of different aggregation functions in SQL Server as well, right? When we'll understand more about the group by clause and all, then we'll again learn about that. But as I'm trying to cover this as well, so here also I'll talk about this aggregation, right? So what are the different by default aggregation operations that we can have? We can have it on the sum, we can have it on the count, we can have minimum, maximum, average, all of that, right? For example, what is the for example what is if you want to get like what is the average salary for the employees, if you have a salary column, so you can use select average, then in bracket salary from the table name. If you want to filter that also, results it on the basis of some column, you can do that as well. So as you can see that we are using this average price from product, something like that. Similarly, if I want to see how many columns are there in this particular or how many records in total are there in this result set, that means how many different rows are there, so I can use select count star from the table name. For example, I want to get it for the employee table. So through this I got that there are seven different rows in this table, right? So for example, if I use the select star only, I can check that how many rows are there. Select star from employee. You can see that there are 7 rows here, right? The count star actually gives the count of the total number of rows in a record. Now, this is not making sense in this scenario, but sometimes we have billions of records in a table. So in order to get that count, it's better to use the count star rather than using select star, because it may take 5-10 minutes also to get the results. So it's better to use count star, and even better to use the count one. Count star and count one both means the same thing. There's only difference in way it works, right? So we should be using count one instead of count star. And I'll tell you later when I'll talk about performance tuning and all why we should be using count one instead of count star. Again, the count can be written in multiple ways, right? Count star, count one. Again, you can use count column name as well. So count column name is actually similar to count star, but sometimes what we want to do is that some column has duplicate values. Like you saw with the first example, we had gadgets 2 times, right? What if you want to get the distinct value of a particular column? So in that case, you can use the count distinct then that column name. Like in the second query, we have written here, select count bracket distinct category. That will give me the distinct number of values for a particular result set, right? So that will eliminate all the duplicates and it will just count the distinct values. So that is another way of using count. Depending upon the situation, depending upon the requirement, you can either use count that column name or count distinct that column. Inside the aggregation, you can perform different operation as well. For example, you want to do the sum of the price and quantity from a table. So in that case, what you can do inside the sum function, you can use the price into quantity. That will give you the price into quantity for each of the rows, and on the basis of that, if you do the sum, that will combine the result set of all the rows together, right? So that is again inside the aggregation operator. You can actually do multiple things as well. You can do the another level of sum, difference, multiplications, and things like that, right? So that is another thing here. Now grouping and aggregation. This I don't want to cover it today. I want to cover it in detail, and that's why I'll cover it tomorrow. I want you to also understand with how do we apply group filters on the group by clause. Like when we have the group result set, how do we apply filter on top of that and all of that. So the tomorrow, the first topic would be to go through the grouping and on top of that using the aggregation operation, right? So this is all for today, right? We'll meet again tomorrow and we'll go through this group by clause and on top of that, how to filter the result set by using the having clause and all. That's all. Let's again meet tomorrow.